Okay, so we're going to have a look at another question. This one comes from the 2022 HSC Advanced Maths paper. So we're told the depth of water in a bay rises and falls with the tide. On a particular day, the depth of water at d meters can be modelled as the following, where t is time in hours since low tide. So part A asks us find the depth of water at low tide and at high tide. All right. So d equals 1.3 minus 0.6 times cosine of 4 pi on 25 times time. Well, the low tide will be 1.3 minus the amplitude. The high tide will be 1.3 plus the amplitude. So we can find low tide is 1.3 minus 0.6, which will be 0.7 meters. And then the high tide will be 1.3 plus 0.6. This will be 1.9, and this is also in meters. So this is just based on correctly identifying the movement of a wave. It can only vary by up to the amplitude away from whatever its origin is. So this is these are the answers for part A. In part B, we're told what is the time interval in hours between two successive low tides. So we just want to know the period. The number in front of the t is b, and we know that the period is equal to 2 pi divided by b. So this b value is sometimes called the period number or the periodicity. So we have period is equal to 2 pi divided by 4 pi on 25. Invert and multiply. We get 2 pi times 25 on 4 pi. The pi's cancel. That's 50 on 4. So that's going to be 12.5 hours. So therefore the period that we're after is 12.5 hours. 12.5 hours. So this is how long it will take for a full cycle. This will be between two successive low tides. So this is the answer to part B. Now for part C, we're asked how long between successive low tides, for how long between successive low tides will the depth of water be at least 1 meter? So now we're trying to solve this equation. We're trying to find particular points at which the tide will be 1 meter. And we might actually choose to graph this to give us some sense of what it is that we're after. So this thing is centered at 1.3. So we'll call this 1.3. We'll call this 1.9, which is high tide. We'll call this 0.7, which is low tide. So it oscillates between the upper tide band and the lower tidal band. Its period is 12.5 hours, which means from wherever it starts, it will do one full repetition when time is 12.5. And this, we might call this depth. Because this is 1.3 minus cosine, cosine of 0 is 1, so this starts at low tide. So it starts down here, and then halfway through at 6.25 hours, gets to high tide, then comes back down to low tide. So it looks something like this. Pretty normal cosine function. It's just shifted around a little bit. So for how long between successive low tides will the depth of water be at least 1 meter? Okay. 1 meter is about here. This is 1.0. So for how long between successive low tides, it's going to be whatever this time period is, which we'll call T1, and then whatever this time period is, which we'll call T2. Now we note because of the symmetry, the time period T1 is actually equal to the time period T2. These are the same. So all we need to do is find the time period T1, double it, that will be the amount of time. So that's what we're going to try and do. We are going to let our formula equal to 1, then try and solve it. That will give us the amount of time. And remember, because it says the depth of water will be at least 1 meter, finding these two times gives us all the time when it's not. Right? So the actual answer will be 12.5 hours minus what we're finding. So now what we're going to do is we're going to say 1 is equal to 1.3 minus 0.6 times cosine of 4 pi on 25 times time. We need to find the time at which this is true. This will give us this value, and pretty much once we've got that value, we know T1, double that, take 12.5 minus double that away from it. That is the amount of time at which the water level is at least 1 meter. So if we minus 1.3 from both sides, this gives us minus 0.3 is equal to minus 0.6 times cosine of 4 pi on 25 times time. And remember, when we do these kinds of equations, we're really just solving trig equations at this stage. So divide by minus 0.6, divide by minus 0.6. This gives me a half equals cosine of 4 pi on 25 times time. Well, this is actually a special triangle value. If you think about our 1, 2, root 3 triangle, we've got pi on 6 up here and pi on 3 down here. So cosine of pi on 3 is 1 on 2. This implies that pi on 3 is equal to 4 pi on 25 times time. Divide both sides by pi. We're going to multiply both sides by 25 and divide both sides by 4. This gives us 25 on 12 is equal to the time. And this is actually time 1. This is the value here, right? This gap and this coordinate here. So for how long between successive low tides will the depth be at least 1 meter? It will be at least 1 meter, let's call this capital T, is going to be the total time, 12.5 hours, minus 2 lots of 25 on 12 hours. So we'll put this in our calculator, and we find 12.5 minus, this is going to be 50 on 12, equals 25 on 3, which is 8 1/3. So we find that the time in question is 8 1/3, and this is in hours. And so this is the number of hours for which the tide is 1 meter or above. And all we had to do was solve one trig equation if we did it this way. This was tremendously convenient. So let's talk about the marking. In the first part, you will get 1 mark for one of the depths, 1 mark for the other. So 1 mark for a low tide, 1 mark for a high tide, something like that. When we move on to part B, you get 1 mark for finding the period and presenting it in the right terms. So 1 mark for the answer, nothing for anything else. The third part is a little bit more complicated. You get 1 mark for attempting to solve the cosine by letting d equal 1. So 1 mark for correctly setting the problem up, identifying that d has to be 1. You get 1 mark for finding the time at d is equal to 1. And then you get the third mark for correctly using that to find the t value that we're after, which was 8 1/3 hours. So this is question 23, and this is how we do it.